It's just solving exponential equations, but using change of base. So if you notice that the bases are the same for an exponential equation, then that means the exponents have to be equal. So if 2 equals 2, then x has to equal 5. It has to be 5. That's the only way for this to work. So when we have a problem like this, what we want to do is turn them into the same base. So we can give an exponent to 4 and make a 16. It's 4 squared. Once we do that, we know that x equals 2. It makes them quick. But you can pick any base you want. So if you said 4 and 16 would be 2. 2 is their lowest. 2 to the 4 would give us 16. And 2 to the 2 would give us 4. But it already has an x, so we put the x on there. So it would be 2x equals 4. Solve it. They both work. So it's your choice. Let's try another. So for 4 and 2 again, it's 2. And 2 to the 1 would give you this one. And then 2 squared would give you 4. But there's already an x, so we multiply it on. Because what's happening is this. This is 2 squared. That's our 4. And there's an x. And that's the multiplication property, right? So if you have a power, you multiply them. So this means that 2x equals 1. Solving it, x equals 1/2. So that is by changing the bases. So if you make the bases the same, you're good to go. So what will be the base for 3 and 9? Exactly 3. So this one is done. We can just bring its exponent down. But 3 squared is 9. And now that the bases are the same, we can make the exponents the same. So subtract 3, divide by -1, and x equals 1. How do you know you're correct? You just have to plug it back in. So if we check it, we plug in the 1, that's 3 squared, and 3 squared does equal 9. Checks out. Same thing with 1/2. Square root of 4 is 2, and 4 squared is 16. Sometimes you can just see them. All right, let's try some that are a little more complicated involving fractions. So if you remember fractions, anytime you see this, this means it's going to have a negative exponent. That's the way it got down here. The negative exponent gave it to the denominator. So our bases, we can make a 4, because they're both 4s already, which means that one is done. And the way that we flip this is to put a -1. So basically it had a ticket, so we give it its ticket back, and it goes right back to the top. And then now we have x equals -1. And that's it. So anytime you see a fraction, you're going to be giving a negative exponent to one of them. So for 9 and 27, you cannot turn 9 into 27, because 9 squared would be 81. It's too big. But we can do 3. So 3 squared gives us 9. And then we just put the x back on there. Same rule as before. And then 3 cubed would give us 27. But since it's on the denominator, it has to have a negative exponent. And that would be 27 flipped. Now the bases are the same. So we say 2x equals -3. Divide by 2. And there you go. -3/2. Alright, this is the most complicated I could think of, and I want you to try it. So, to give you a hint, remember radicals are fractional exponents. And the base here would be 3. So pause and give it a shot. Okay, so over here you have -3, because that's what we had before. And this is a half, so it would be 1/2 x. But what I like to do is go back to what we did before, and that would be x over 2. So if you remember our exponent rule for it, anytime you have this little situation, that's the numerator, that's the denominator. So for us, that's the numerator, that's the denominator. So it's x over 2. And now that we have that, we can say that x over 2 has to be -3. And we can cross multiply. So x equals, x times 1 is x, -6. And that's it. Alright. So here's the one that is our very special one, which is why we're going to do it together. So they don't have the same bases, and that's the key, is they all have to have the same base. So we can turn a 2 into an 8 by cubing it, a 2 into a 4 by squaring it, and a 2 can stay the same. So now we do that same rule. So 2 cubed would give us 8, but we already have the x plus 1. So we put it like that. And then 2 squared would give us 4. Okay, so this doesn't hit our property yet. The property says they have to have the same base, and there only is one of them. Over here, it's not a clean comparison. We're multiplying. So for multiplication, you add exponents. So this would be 2x plus, and then I'm going to distribute 3x plus 3. Now they're exactly the same base. So this whole expression, which is 4x plus 3, would equal 2. And now we can solve it. And there it is. And there you go. So again, there's not one way of doing these. There's a bunch of different ways. But the main idea is to have the bases the same.